Hey gang, I kind of wanted to review a little bit and just make a little video clip of this review sheet we did on the day of the sub. So this first problem, remember how this works. If we want to graph this, we can tell what the zeros are. You can see the 1, 2, and 4, so we can put dots there at 1, 2, and 4. And then we could get a y-intercept if we wanted to. So you always plug in 0 for all the x's whenever you're looking for a y-intercept. And I plugged 0 in and I got 4/3, so that gave me this dot right here. And then really you just need to get the beginning of the graph, and then you can use multiplicities in the zeros to figure out what's happening after that. So I actually plugged in a 5, it looks like. Plugged 5 in, and it turned out it was a negative number. You can tell that it turns out to be negative. So if I'm at 5 over here, and I can tell that it's negative, and actually it looks like it was 5 negative 2. So then I'm negative, and then I hit the 0 right there at 4, and because it's odd right here, the odd power, that means it goes through the 0, it goes up, comes back down at the 0 of 2, and then because that's a multiplicity that's odd, it goes through the 0, and then it goes back up again, and it hits the 0 of 1, and it goes through it because of the multiplicity of 1, and then it just goes through the y-intercept, and then keeps going up. Okay? And then when you look at the sketch of the graph, it's pretty easy to tell when f of x is greater than 0. It's when it's above the x-axis. So you can see that that would be negative infinity to 1. And then you can also tell, again, that from 2 to 4, so we would union those two from 2 to 4. You can see when it's above the graph, above the x-axis. And then f of x is less than 0 when x is in the interval from 1 to 2. You can see it's below the x-axis there. And then from 4 to infinity, you can see right here that it's below the x-axis. Okay? Next problem, intermediate value theorem. Let's see, I need to do something real quick here. Intermediate value theorem, we want to show that f has a 0 between there. All we're doing is really looking for a sign change from 0 to 1, and then that'll do it for us. And we plug in 0, we got negative 3. We plug in 1, we got 4. So there is a sign change, so that guarantees that there's a 0 between 0 and 1. The long division, I won't review that. You can review that. Synthetic division, I think you guys remember that. Just remember that the powers have to work out here. So you've got to be in descending order, so you'll notice I'm missing some things. So we got to plug in zeros for those place settings. It goes 5, 4, 3, 2, and then 1. You can see we're missing another one there at 0, at x. So we got to put in a 0 for that spot. All right. And the next one, when you have the zeros, you just do x minus each of those zeros. And then we leave a little a in there because we're trying to figure out exactly what the a is, and we utilize the point that they give, and we plug that in. Plug in the 3 for all the x's, the negative 24 for the y's, and then solve for a. So it works out pretty well. Once you get the a, then you can probably just leave it in this factored form. That's okay. All right. Next one. If you want to state the zeros and the multiplicities, you've got to factor that. So we factor by grouping. It has 4 terms. So we factor by grouping. We take out, what we can out of the first 2 terms. Need a little skinnier line here. Okay. So we take out the x squared. You can see that, and we see what's left. We got x plus 2 left over, and then out of the second 2, we take out a negative 4. And we see that there would be an x plus 2 left over, and then we take out an x plus 2 out of each of these, and then we're left with x squared minus 4, and then we factor that a little bit further as a difference of squares. All right, and those are your zeros. And then the multiplicities are just, we have a 0 of -2, and then we have a multiplicity of 2 for that one because we have it twice, and then we have a 0 of 2 and a multiplicity only of 1 for that one. Now Descartes' rule of signs, I think we're pretty good at this as well. We're just looking for sign changes of the coefficients. So I'll have the work shown there. You probably don't have any questions about that. Negative real zeros, that's where we plug in a negative x for all of the x's and then do the sign changes again. Your list of possible rational zeros for that next problem, that is doing the C over D. The C being all of the factors that go into that constant. And so pardon me. The numbers that go into 56 are all those, and then all the numbers that go into the leading coefficient there, so that's plus and minus 1. And C over D in that case was exactly the same as C. For a problem that says find all the solutions, go ahead and start with your C over D list. All the factors of 6, all the factors of 1, and then try some out and see if you can get your zero remainder, see if you can figure out, get a lucky guess and figure out which one is the zeros. And then what that'll do is that'll make your polynomial a little bit more depressed. And once you get it depressed a little bit, then go ahead and use the depressed polynomial and try some more zeros until you get it down to where it's actually quadratic. And then once it's quadratic, you can say what the polynomial is, and then set that equal to 0 and use your quadratic techniques to figure out all the remaining zeros. Okay. And then for number 12, that one, you're given the zeros again, and remember these guys, the complex zeros, they come in pairs. So it's x minus each of those, so there's just some little bit of messy algebra, but actually not too bad. And it's degree 3, so we know those guys come in pairs, and then we have the extra x minus 2. We just do all the distributing there, and we're good. Number 13, find the vertical asymptotes. That's always going to be the denominator. So we look at the real zeros of the denominator and see that after we factor it, it's pretty easy to tell that -3 and 2 would cause the denominator to be 0. Those are our vertical asymptotes. Number 14, the X-intercepts are always the zeros of the numerator. So we factor that, and we can tell that 4 and -1 would cause the numerator to be equal to 0. So our X-intercepts are 4, 0 and -1, 0. And the Y-intercept is always plugging in a 0 for the x's and then seeing what you get. So you're plugging the 0, you get 2/3. And you can kind of see that. If you cover this up, you cover up all the x's there, you would have 2/3. All right. So good enough, I think. Let me see if there's anything else here I want to talk about. A little more of the same. Show that it's a factor. Whenever you want to show something's a factor, you just take the 3, put it in the box. That 3 is a 0, by the way. The factor associated with that 0 is x minus 3. So we do synthetic division, that's one way, and we come up with a 0 remainder. So we say, hey, 0 remainder, therefore it's a factor. Okay. Number 13, that was just a little synthetic division. Zeros, same as that other one. Descartes' rule of signs, find all the solutions. You notice we try all the factors going to 30, and then it just keeps getting depressed. That number there, 37, I believe, we run through all the steps that we've been doing, 1 through 6. So, I don't know if I'll do them all again here, but you can see the steps. And actually, let's see. No, I don't think I'll run through all the steps right here. Then 38, all the steps again. This one was an oblique. Was it? Let's see. Yeah, this one was an oblique. So we had to do a little long division. And we got x minus 1 as our oblique asymptote. And then these don't define. Alright, so that's it. Cool.